Hi. Well, I would like to talk to you today about dependency injection. I would like to explain a little more about what it means to containerize some classes. I, by doing so, assume that you know what's object orientation, that you're already able to write your own PHP class, that you already understand the different type of classes, which is kind of wrong way of putting it. But in JCB we call it powers. We created this area where you can create any kind of PHP class type. And yet this area only really comes to its full potential when you actually understand what is dependency injection. And if you use the DI, that's dependency injection container, and so instantiate your classes, you'll get the full potential of the new feature which we are releasing called superpowers, which is basically a smart way of distributing of code and including projects, code projects in other projects. So without much further explanation, let's look at some of the reality on the ground. So here we have a Joomla installation. In fact, it's JCB Builder's own installation. I'm scrolling down to libraries here, and there we see JCB Powers, and the folder where all the powers are placed. Now you could rename that folder in your global configurations, but I'm using the default. And then we see there are subfolders here, and we want to look inside of this Joomla source component builder folder. Now you'll see that there are services folders. Now all the services are folders which contains service providers. Now the way I think about service providers is a way to collectively combine, a way to combine classes that belong together. It's like a grouping thing. But it is also the place where you actually tell everybody, that means the dependency engine, container, rising, DI, you tell it how to instantiate your class. So service providers is that's from my point of view, a way to group classes together that you want to use in your application. And then also to explain how to instantiate those classes. Now, what does instantiate mean? Well, if I open this service provider and I double click here on Gitty, then you see we only have, because we're in the upper layer of my application, and I know that there's parts of Gitty that I need not only in the compiler, but also in the packager, also in other areas. I have moved those classes up higher in the folder structure. And how did I do that? Well, in the way that I declare its namespace. So its namespacing declaration is what places it in a higher up folder. And so here we are instantiating the URI and HTTP class, which is part of the utilities needed for the Gitty application or the Gitty classes. So I know that instantiating it on this level, we will have access to the config and getting from the config certain values, and if it can't be found, we will instantiate the utilities URI, which is declared lower down in our application. This also is for the HTTP. We are basically pulling the token from the config class and instantiating. Now, you'd say, well, from the config class, what do you mean? Well, this here, this container get config, it's basically triggering a key by which we are instantiating the configuration class and then using a function in the configuration class, which is get. Now, the first time that this ever in the application is called, at that very moment, it instantiates the config class and it stores it in the container's memory. And from there on, keeps using the same class. And that's one of the advantages of the containerized approach. You always call your classes out of the container, and when they get instantiated, all their dependencies that they need to be able to function correctly gets pulled in as well. So it's a very kind of prevents a lot of complications trying to always reinstantiate classes as you need them. This way it gets instantiated once. Well, you could do it differently. You could instantiate it not only one time. There is a way to do that, but in most cases this is what you want. You want the class to exist in your application once, and wherever you need it, anywhere else in your application, it's going to use that same instantiated class. Now, what does instantiate mean? It's when you say new, right? New config class. And now usually if we open, for example, the URI class is coming up in here, right? It is utilities, Gitee utilities URI. So if we go into, let's see, to quickly find myself. Oh, there we are. So here is Gitee's utilities URI. There's the class. When we open that class, we see that that class needs a URL. It needs an endpoint and a version. Now, the endpoint and the version is at this stage not going to be changing anytime soon. But we might have a different URI or URL for this instance of Gitee. So the Git application can point to multiple instances of Git or Gitee, which is the actual application. And so because we are allowing that, we are instantiating it by saying, have you added your own custom URL? And if so, then also get the value. And then we check whether the value is 2, which means you've activated it. And we check whether the URL exists and whether it has the HTTP value in it. And then we basically instantiate this URI class. Now, from here on forward, the URI class knows how to start itself up. Okay, so here is the constructor which needs certain values, and here we are basically passing that value. Now, if we don't, and you see here I have another way of calling the Gitee utilities URI. Now, that means there must be another declaration of it. And so if we go to the services in the Gitee classes, and then we go to utilities, we'll see that yes, here is the Gitee URI utility declaration. So this is the key. This here is the key of getting that class again later from any other point in your application. So looking back at what we've done here, I'm basically saying, do we have a custom URL? Then instantiate it. If we don't, fall back to the default. And so the default, what does that do? Well, it just instantiates it. Now you could say, why didn't you do it over there? And you're probably right. I just liked falling back to the default. So that if the default changes, that I don't need to be concerned about many places, just one place. Now what is the default? The default is our system. Okay, so since I'm not passing a URL, it is falling back to the BDM system. And so now we have the Gitee dynamic URI declared. And so from here on forward, I can just use this key to pull the actual entry point URI for the whole API of Gitee. And I don't need to think about that again. So if I then go to, let's say, the repository service, which is again another service provider, if I open that up and I scroll through it, you'd see that I'm declaring again a bunch of keys here, right? So these are all keys to getting classes. And then down in the lower part of the file, here I am using the utilities HTTP, the dynamic URI, utilities response, which again already was declared in other service providing classes. And I'm basically just pulling them here. So the way the container works is that it basically keeps a register of all these declarations. So this here is the place where you do the register. So the register passes in the main container, and you are basically chaining into this register aliases and shared connections, which then later, if such a call comes up, then it instantiates that class. And it doesn't do so until then. So you cannot really bloat the system considerably with a lot of service providers, because the instantiation takes place when the class is called, not when the class is explained, if that makes sense. Here you are explaining how it works, whereas here you are actually instantiating the actual class. And so whenever you then from here on call this class again in any other class, it's like a net, it just pulls in all the necessary classes, and immediately they're all correctly instantiated and available. Now, having said all that, what do we do when we now have all these service providers? So like you can see here, the Gitty system has a folder with a whole bunch of service providers. And you may not even need all those classes. So there is a way in Joomla 3 which we are currently making use of these service providers. Going to Joomla 4 is going to become even more easy to implement. Joomla 4's whole architecture is driven by providing service providers. So you're basically preparing yourself to easily adapt to the Joomla 4 architecture. This being said, in Joomla 3, what we currently are doing is we are making use of what's known as a factory class. Now I know the factory class is frowned upon because it's seen as a, anti-design pattern. It's kind of an anti-design pattern. But it works brilliant for what we need. And that is a single point of entry to pull in or to pull from any class we need in our application, which is really what your container is supposed to be. It's a place where you can call your container and get things from it without any reinstantiation or redeclarations, trying to struggle with getting your instantiations to be unified. This is exactly what this approach helps you achieve. And so you will see that in every one of these grouped, sort of super grouped, like this one is now the Gitty grouped folder, you'll find a factory class. And in the factory class, I am basically pulling in all the service providers, and then I'm creating a singleton static container, and I create this underscore key function. And what this underscore key function does, it gives me a simple way to say, give me this class, give me that class. It's basically what it's doing. And it's simplifying this out of the way. So I don't need to say get container, it just makes it simpler. And it makes sure that I'm just working with one container, no matter where I am using this, it's everywhere the same one container. Whether I'm working with it inside of the container or outside of the container, I'm coming through the same entry point. And this means that now if the container does not exist here, it's going to check, does it not exist? It instantiates it for us. And this is basically how you instantiate the container. You just new container new and registering that service provider. And in this process of registering all the service provider, you're basically telling the container, if anybody asks for this class, this is how you get it. That's all. You're just basically telling the container everything it needs to know to instantiate your classes. Once all of that has happened, the container is now basically ready to serve. And from here on, we are returning the container and obviously just calling the get method on it and getting the class and using the class. Now, I do admit the container itself has so much more to offer, but I like to first master the basics and find myself quite capable of making use of that advantage and then taking the next step. And so this is something that will grow and increase. And especially as we step over to Joomla 4, this is going to be brilliant. You're basically going to be ready to pass things into the container and just you make use of them. So having said all that, we now have to use the factory class. And the factory class now has many resulting functionality. What is this? Well, anywhere in your component, in any custom area, you can now simply call the factory class, give it the key that, you know, when you declared the service provider declared it by a key, right? This is the key. And if you give that key into this factory, basically that same key, then you're going to get that class. And you're going to get that class completely, perfectly instantiated and functional. So you can just start using its public functions. And it's going to be very simple and easy to use it. That is one advantage. The other advantage is inside of classes. For example, if we go look at the repository, let's go back there. The repository class, it's this one. You see here that we are extending the API. So yes, I am not against extending, and people can agree with me, but that's fine. So basically what my API abstract class is all about is just taking care of my constructor. So here comes in my classes that the container is injecting into this class. And then I have a little overriding load method, so that if anywhere in the query I need to change from one Kitty system to another, I'm able to do that. That's all that is for. So it's a useful function. Now, going back up, we basically here, we recognize that we actually have the following in our class. We have the URI here, we have the response class here, and we've got the HTTP class. And so now we don't need to be concerned about how those classes come into this class, because our container is taking care of that. We can just directly start using it. And because we are using it by inheritance, we're able to come over this class, click on it, and it will take us to the class itself if you've got an IDE, and you could get to see the functions of that class quite easily. And so this way of design still works well with an IDE. You're still able to follow the classes, you're still able to see all the methods and be able to use them as usually. So this is the other implementation, which is kind of out of the box. You don't even think about it. And that is that putting classes one into the other and making use of classes amongst each other is now simplified, and you're basically removing a lot of complexity out of your application, and you can just directly start using classes in other classes. So this kind of behavior can get quite overwhelming. If I go over to, for example, the admin view in JCB, here, these are all the classes that gets injected into the admin data class, admin view data class. So this is a lot of classes to take care of, but because we're doing it through a container, it's basically a breeze. Now I have another functionality here, but it's a temporal one, and I probably should stop doing it. And that is this, this that you see here. What this is doing for us currently, it's kind of trying to ensure that even if someone would directly instantiate this data class of the admin view, so let's somebody did it in the old school way, like include and then new, which is obviously horrible, but it, you know, people do strange things. So if they did that, What this approach is trying to achieve is that it will still use the container. So if you look at the container, it's basically the factory class. So we're basically pulling in the factory class over here. We're just giving it the name compiler. And we are basically saying, oh, you didn't get me through the container. Well, I'll still use the container to populate myself, and basically instantiates all the necessary classes this way, so that you kind of have a consistency, that even if somebody broke out of the container approach and instantiates your class somehow separate from the container, it still reaches into the container to get its dependencies. The sad part about it is that this is not best practice. In fact, I can see that we will eventually remove this from future versions of this class. Simply because why? Why have it there? Why even think about using it any other way? So this is a temporal workaround for any unexpected application. But in the long run, that's not really necessary. And so we have all these classes pulled into this one class through the dependency injection. And then we're able to use those classes in our code down here, one after the other, based upon the data that we've got back from the database. And it does downsize your functions, complex functions. It's really an important transition to go from very long, bulky methods, classes, to smaller classes, much smaller methods. Methods no longer than 10, 20 lines. Most will go even as low as 5 lines. So to crank down all your code to smaller bits and little blocks of bytes is what is the objective. This helps creating a whole bunch of opportunity of modularity. That is what you're really looking for. There's a whole bunch of principles that every one of you must actually know well, and it's almost like something that you must exercise. You must kind of remind yourself about and make yourself very familiar with it. And it's called solid principles. Now let me open a web page here. If you go to this tab here called Joomla Component Builder, and then to Joomla, and then last page at the moment, because it's been unchanging for so many years, you'll find a repository called Solid. Now Solid is an acronym that stands for these different phrases: single responsibility principle, open close principle, Liskov substitutional principle, interface segregational principle, dependency inversion principle. These are the foundational architectural sort of thought patterns that is required for you to reinvent, re-understand, if not already, how to approach object orientation, how to build classes, how to connect classes. Now, though I am aware of these things, and though I am definitely agreeing that these are the best way of designing, I'm also aware of the obvious reality of the industry. And so there is this fact that I'm trying to implement this, but not in a way that, you know, I'm kind of upset if someone didn't do it exactly the way that I would have wanted it. So I still believe in the artistic freedom of software engineering, which sounds kind of contradictory. But it is true. There is different ways of making things, and taking all these, I would say, good practices, good design patterns. There are design patterns which we didn't even touch today, which is very critical for you to grasp and get your head around. So do Google search, YouTube search, do research, go to places like Udemy and others, and try and school yourself in good design patterns. There are many different types of design patterns, and we don't have enough time today to go into that. But as a start, in preparation for making use of JCB's power area most significantly, you need to get your head around dependency injection. Now, I haven't showed you how that is done in JCB, but that's basically because I would expect that if you grasp these things, you wouldn't need me to tell you how to use the powers area, because it's kind of says it up front. You know, the naming of the fields, the selections, the tabs, the checks, all of those things are the actual terminology of classes and object orientation. And now this extra layer of service providers and factories are just a different way of coupling and kind of integrating your classes together, bundling them, and where your factory is the main bundling method. Because when you then pull the factory, it pulls everything. And when I say pull, I mean every class has a global unique ID. And this global unique ID becomes part of what we call the SPK, Superpower Key. SPK is a key that you can use in your custom code, which I will do a tutorial about. And when you do that, JCB will basically use this key to pull that class into your project if it's not already in that specific JCB instance. It will pull it from your repositories. Now, if you don't have it in your repositories, it will drill down until the core superpower repository, trying to discover this key. So we have a new method with which we are able to pull code from other repositories into your project without you having to do really that much except using the key. And because you are using the key of a factory, everything is connected to that service providers, which are in that factory. So as soon as you pull the factory, it starts pulling the service providers starts pulling the classes starts pulling their interfaces, and so it goes on and on. It's like this bag that you are pulling, and it pulls all the relevant classes into your project automatically, just because of how the linking system in JCB works. Having said that, I will illustrate that in the next tutorial, and hope to see you there. Thanks so much for watching. Take care.